Find the prime factorization of 300. So let's take a look at these divisibility rules here. Okay, and we're looking at 300. The last number is even, so 2 can go in there. What else? 5, if the last digit is a 5 or a 0, you can divide by 5. And there we go, we have a 0. Also look at 10. If the number ends in 0, it's divisible by 10. And 2 times 5 is 10, so it should make sense that if a 10 can divide in, both 2 and 5 go in there also. Let's do some dividing now and see how things come out. Now the first thing I'm going to do is what's called a factor tree. I'm going to start with a 300, and I'm going to make 2 branches. That's why it's called a tree. And I'm going to take a 2 out of here, and I know that there's a 150 left over. And I'm going to show you some other examples later, but I'm just starting with a 2 because I know 2 goes in. And 150, you know, that's still, well, I think that's what, 15 times 10? So I'm going to put a 15 and a 10. And now I'm going to factor each of these. Notice I didn't continue with a 2 because that's already prime. But this 15, that's 3 times 5. You can always use a calculator to help you too when you're doing this stuff. 10 is 5 times 2. Okay, now all of these factors are prime now. Let's take a look. We have a 2, a 2, a 3, a 5, and a 5. These are all the prime factors. And you can circle them if you want to show that they're prime. Nothing wrong with that. So I'm going to write my factorization starting with the smallest number and just continue. So it's going to be 2, 2, 3, 5, 5. If you multiply all these numbers together, you can get 300. And you might as well check that on a calculator real quick just to make sure. So it's 2 times 2 is 4, and then so on and so forth. You can go ahead and verify that yourself. I'm going to do another tree. Only this time I'm going to work it out a little differently. Instead of starting with 2 and 150, I'm going to go ahead and use, 10 times 30, because I know that makes 300 also. So then I'm going to take this 10 and do 2 and 5. And then this 30, I know 6 times 5 makes 30, so I'm going to put 6 and then 5. Now 5 is prime, 6 is not prime, this 5 is prime, and so is the 2. So I'm just going to do this 6. 2 times 3 makes 6. So they're all prime now. 2, 5, 2, 3, 5. So I have 2 2s, 1 3, and 2 5s. That's the same thing I got here. Now the reason I did a second tree is it doesn't matter how you start with a factoring. As long as you get the correct factors each time, you'll end up with the same prime factorization no matter what. And that's pretty cool. Let me show you one more method of factorization here. I have to make a little space. Okay, now this one is called just division. Some people call it upside down division, but it's not really upside down, so I'm just going to call it division. You start with a 300, and then take out a prime factor. And since it's an even number, I'm going to take out a 2, and that leaves 150. And like I said, you can use a calculator to help if you want. Still an even number, so I'm going to take out another 2, and that's going to leave 75. Now this number ends in 5. It's not even anymore, so I can't take out another 2. But I can take out a 5 because it ends in 5. So 5 goes into 75. It's going to be 15 times. And remember, you can use a calculator to help if you want, or you can write out the long division. Now 15 is 5 times 3. 3 is a prime number, so I'm done. These are all the prime factors, 2, 2, 5, 5, 3. It's the exact same factorization that we got with a factor tree. But here you have 2 different methods you can use for finding the prime factorization, and you can use whichever method you like. Or you can do them both and then compare to see which one you like the best. So here's how you write your answer. And if you want to, when you're entering your answer, you can put an asterisk in between instead of using parentheses. You can write it like this: 2 asterisk 2 asterisk 3 asterisk 5 asterisk 5. You can write it either way with parentheses or with an asterisk in between each factor.